students, welcome to IMS Gate Academy. But in this session, I am going to do the questions which were given in Gate 2021. But in that paper, I selected the EDC questions, and I am doing here now. I am going to do now the problems on EDC. The students can understand easily. So the first question from the EDC Gate 2021 EC paper. The energy band diagram of a p-type semiconductor bar of length L. So given semiconductor is p-type semiconductor bar. Its length is given L. Total length is given L. This length only. Under equilibrium condition, it is an equilibrium condition, that the Fermi level energy EF is constant. If it is in equilibrium conditions, you can find Fermi level constant, no doubt, as shown in the figure. The valence band EV is sloped since doping is non-uniform. The point here given, it is a uniformly doped or non-uniformly doped, it is specified in the problem. It is, how it is doped? This is non-uniform, here given. This is given non-uniform. That's given non-uniform. Along the bar, the difference between the energy level of the valence band at the two edges of the bar is delta. That means the slope we are getting because of the non-uniform. Non-uniform, what now? Doping is made. If it is uniformly doped, you will get one straight line only here now. There is no slope here now. Here the slope we are getting because of the non-uniform along the bar only now. And also the difference between the energy levels, it is given now. Valence band and two edges of the bar is delta. That means the energy between these 2 points is given delta. Delta is the symbol given here now, the energy level. If the charge of an electron is a Q, we know very well the charge of electron is a Q only, then the magnitude of the electric field developed inside the semiconductor bar is. What amount of electric field is developed inside of the bar is must. It's a very simple question here now. The solution I can complete here directly. It is non-uniformly doped. The electric field, I want electric field developed only here now. Electric field I want. Electric field, how we can determine? You know very well, the electrical, the voltage by distance can be taken as a, voltage by distance can be taken as a electric field intensity only now. Okay, the electric field clearly, if you want, means potential developed divided by potential developed divide by thickness or length. Thickness only. This total thickness or total, the thickness only L we have taken here now. But in this case, potential developed is nothing but the energy level, maximum energy level is given between these two, delta only now. But if you want to get the what now, potential means the energy level is to be divided by charge. When it is divided by charge, you will get the voltage in volts only. Potential is available. There is a potential developed equal to what? Energy level between these two must be divided by Q. Then only you will get the potential. Potential equal to energy level between these two divided by Q only now. Divided by thickness. Thickness means total length only. From here to here, length is L. And finally, this is the electric field intensity. I have taken E. E can be taken as a delta by Q into L. I can write it here now. Such a way, the electric field is calculated. So which option is correct? Q into L. Option A is correct in this problem. This is the right option only now. It's a direct question only now. Understand now. Yes, now I will do the next question now. This is given here now. But in this problem, one diagram also will come that I will draw now. You will understand now clearly. But here the one diagram also is there now. Below that one I will include. There is a diagram. This is a p-type. It is given because as shown in the figure is given. That figure is this only. This is 1.2 micrometers. 1.2 micrometers, this one. This is n-type. This is 0.2 micrometers. 0.2 micrometers it is given. That's all. This is the given. Anybody can do this question? Still this question is given like this now. The magnitude of the reverse bias voltage that will completely deplete one of the two regions prior. Anybody can do that question? Just to try at first. Anybody can try this question? How we can do this question? Anybody? A silicon PN junction is shown in the figure. PN junction diode here now. The doping in the P region is a 5 into 10 power 16 per cm cube is given. And in the N region is a 10 into 10 power 16 per cm cube. The parameters are given, certain parameters here now. And the problem, what is asking to find the magnitude of the reverse bias voltage that would completely deplete one of the two regions prior to the other, rounded to one decimal place. That is the given problem. Here I wish to note down the data which is given in the problem only now. What is given now? A bar of what now silicon with a boron. Sorry, it's moved I think now. A silicon PN junction, doping of the P region is given now. Doping of the P region indicates what? N suffix A, acceptors concentration is given. I will do the solution here now. Acceptors concentration is given in the problem. Na value is given. What Na value is given here now? 5 into 10 power 16. 5 into 10 power 16 is given per cm cube. That value, that is Na. And what about the next one here given? And doping in the N region is a 10 into 10 power 16. Doping in the N region indicates N suffix D, donor concentration is given in the problem. Nd is given in the problem. That Nd is given as how much? 10 into 10 power 16. 10 into 10 power 16 per cm cube it is given. Per cm cube it is given. And also here given built-in voltage is given. Built-in voltage means a 5BI or VBI acceptable now. I will write VBI otherwise. VBI, the VBI is nothing but the 5BI also. Anyhow, built-in potential is given. How much? 0.8 volts. 0.8 voltage it is given. And also here given the charge is we know not required. Epsilon naught we know 8 into 885 into 10 power minus 12 we know very well. Farads per meter is given. And relative permittivity 12 it is given. Relativity permittivity 12 for the silicon is given. The magnitude of the reverse bias voltage that would completely deplete one of the two regions only now. That means if you are connecting to the this PN junction diode, this PN junction diode reverse bias voltage you applied. Reverse bias voltage means p-type is given to the negative electrode, n-type is connected to the positive electrode only now. At the time, what is going to happen now? If you connected in the reverse bias, what is given here now? If it is given reverse bias, what he says, the magnitude of the reverse bias, that voltage only required, reverse bias voltage required, that would completely deplete one of the two regions, prior to the other. That means out of these two, the two regions are there now. When the reverse bias is made, one of the region will be depleted, totally removed only now, totally removed. PRN, that we can identify only now. Understand now which region is completely removed, that is required now. What voltage is required? What potential reverse bias voltage is required to completely deplete the one of the region only here now. How we can determine? If you want to find out the that reverse bias voltage, initially you need to know the width of the the depletion width in the p-type and n-type. We need to find out depletion width where the p-type and n-type is more important. Based upon that only we can understand depletion width this side is a more or this side is a more. We need to find out. Wherever you are finding the higher constant, but first I will calculate, then after I will explain clearly. First we have to find out the depletion width, how it comes. We know very well one of the condition we know from the PN junction diode. By using that condition only we are going to do. That condition is to be taken as a NA into, we know very well, NA into XP, NA into X suffix P. NA means acceptance concentration into what? The width in the P region is equal to ND into XN. This condition will be satisfied the any PN junction diode. But in this case, NA is given XP, XP and XN relation I want to get now. Using that relation only, I can do the question only now. NA is given 5 into 10 power 16 into XP here, ND is nothing but 10 into 10 power 16. Why we are applying this formula, you can understand now. Into XN we got here now, XN we got. Here I can cancel 5, 2 times I can cancel here, 10 power 16, 10 power 16 I can cancel. Finally, what I am getting here now, XP is nothing but 2 times of XN I am getting here now. Catch my point. XP equal to 2 times of XN I got it now. XP is a width of the depletion region in the p-type. P side is a more or n side is a more here now. We are finding XP is a large as compared to the XN only now. In that case, we can say this side XP and XN if it is taken here now, but this XP is nothing but a depletion region this side, XN is this side. 2 times mostly it is possible. 2 times we got it now. From this, what I wish to say, XP equal to 2 times of XN we got it now. When the reverse bias is applied, when reverse bias voltage is applied, reverse bias voltage is applied. Whenever the reverse bias applied, what is going to happen? Reverse bias voltage is applied means one of the region will be completely depleted only now. Which region will be depleted easily now? N-type region will be depleted. Reverse bias whenever you apply, this region will be depleted very fast, because this total length is a very small only we got now. That means these are initially XN I got here now. This is XN I got here now this side. That XN when the reverse bias is applied, this total length is a very small. Easily it can deplete only we can say. This cannot deplete very fast. This can deplete very fast only, 0.2 micrometers only now. There's a depletion which side it is possible means N side only is possible now. Totally depleted means this point will reach to this point level. That means what I wish to say, this XN is nothing but, XN can be taken as a what? Here I am writing you watch. XN can be written as a, XN can be taken as a 0.2 micrometers only, same 0.2 only, because totally depleted XN is This entry is a depleted only. That's a 0.2 micrometers it can occupy. That's why I can write 0.2 micrometers only this now. If it is 0.2 micrometers, what is XP value here? XP value 2 into XN, 2 into 0.2 micro. It becomes a 0.4 micrometers possible now. Why these values are required, you can understand shortly now. This XN plus XP, if the both are added, means total width is available. Total width of the depletion region. What is the total width? Total width is nothing but XN plus XP. That value 0.4 plus 0.2, 0.6 micrometers it comes. 0.6 micrometers total width is available. Yes, we got the total width. This width I got whenever the biasing is applied, reverse biasing is applied. Catch my point. When the reverse biasing is applied. In case you are not applying any biasing, that is what when the supply is not connected, you think it's so. What is the width? That width also required. Why that width you can understand shortly now. That width I have taken W naught. W naught means when diode is, when PN junction is unbiased, I have taken here now, unbiased. Whenever it is unbiased, what width is possible now? When the total width I want to find out now. Total width when it is unbiased. This I got when it is a biased. Only when it is a biased, I got that what now? Total width only now. Unbiased means we know the formula in the PN junction diode. What is the formula for unbiased? Under root of, you know very well. That formula is taken under root of 2 into epsilon naught epsilon r into divided by Q into 1 by Na plus 1 by Nd. Formula is there. Into VBI. VBI or otherwise 5BI. We can put now into VBI. Into VBI they will apply. Yes, that formula is applied. But the formula is for unbiased, I can say, W naught. But this W we got for what now? Bias. Only for the bias only we can say. Understand now. Now I wish to find what is W naught. Why these values we'll understand within 2 minutes now. 2 into epsilon naught. Epsilon naught is given already 8.85. 8.85 into 10 power minus 14 it comes, 10 power minus 14. Why it is a 10 power minus 14 means already it is given here. What is given? 10 power minus 12 is given. Farads per meter only given now. Farads per centimeter I want to convert. Farads per centimeter if you want to find means what you have to do? 10 power minus 14 is possible. Relative permittivity also given. What is the relative permittivity? 12. That's given 12. That's given 12. Divide by charge 1.6 into 10 power minus 19 and into 1 by Na. What is Na? Na value is given here now 5 into 10 power 16. 5 into 10 power 16 plus 1 by Nd. I am writing below only now. 1 by Nd. 1 by Nd. I am writing here now this value. 1 by 10 into 10 power 16 into what? That value into what value is required? Into VBI. VBI is nothing but the 5BI, 0.8 into 0.8. So you will calculate what is W naught value. So finally this W naught is, I can write here now. Finally this W naught is taken as a I can write W naught, I can get here now. W naught value will be, that value comes as, I'll write that value, 0.18. 0.18 micrometers possibles. That much W naught is possible now. I got already here, I got what value? W 0.6 micrometers. When it is a bias. When it is unbiased, we got, when it is a unbiased, I got this value. So now we can understand why these W0 and W values are required. That is more important now. because my aim is to find out the VB, when it is a reverse bias, that PN junction diode, what potential is required, reverse bias voltage, how much it is required now. So, we know very well, we know one formula from the, we know that only now. From the PN junction diode, we know W is directly proportional to under root of junction voltage, under root of junction voltage only now. Based upon that point only, we are going to calculate only. Here the ratio I want to use, what ratio? W by W naught, W value, that value, W by W equal to W I have taken out, W equal to W naught, I want to divide. Whenever the junction voltage, how we can get? In the electronic devices, you know the formula only now. Junction voltage is calculated by what formula? For bias. For bias means they will apply VBI plus reverse bias voltage only, VR value. VBI plus VR is said to be what? No, junction voltage when it is bias. When it is bias. Whenever the W naught is nothing but the unbiased. Unbiased means VR will be 0 only directly. We are not connecting any reverse bias voltage only. Directly VBI only possible here now. Directly VBI possible. That's why I can write this is equal to what I can write, this by this 1 plus VR by VBI is possible. And directly you can substitute values. W value we know very well. W value is 0.6. Both are micro cancel. 0.6 micrometers. W naught we know 0.18. That is equal to under root of, we want reverse bias voltage VR, VBI built-in potential we know very well now. What is the built-in potential here now? VBI value will be the VBI value we know very well. How much we are getting VBI value is given here now? 0.8 voltage is given. 0.8 voltage is given. Now use calculator and find out the VR value. VR value will be, finally the value of VR will be, it comes as 8.1 voltage is available. 8.1 voltage is possible. Reverse bias voltage is nothing but 8.1 voltage is mostly possible now. This voltage becomes 8.1 voltage. This is 8.1. That much voltage is possible. But try to understand, in a problem PN junction diode is given. That PN junction diode, what happens now? When the reverse bias voltage is applied, one of the region will be completely depleted only, says the now. In this case, we are calculating at first, when it is biased, what is the W value we are calculating. When it is unbiased, W value we are calculating. By using the W formula, we are dividing the now with, we are getting the what now? VR value. Such a way we need to tackle this question only, we can say now. I think you followed. Once again you practice 100%, you will follow only now, understand now. Next one. This is one more question. GATE 2021 EC, a bar of silicon is, anybody can do this question without my help? I will wait, please complete. You please try to complete this question without my help. Anybody can do this question without my help? Anybody? Would you take your time and give answer? Just 2 minutes to try. I want to give time for 2 minutes. Anybody can give answer? Any chances? Okay, I will do, please watch. What is given in the problem? But options also given here now. Which option is correct here required? A bar of silicon is doped with boron concentration. If it is a silicon is doped with a boron concentration, means is it a p-type semiconductor or n-type X6 semiconductor? It is a p-type X6 semiconductor, no doubt it is a p-type. The concentration is given, Na is given in the problem. This is Na value. I will put there now. I will put this as a Na value given. Solution. In a problem, Na is given in the problem. Acceptors concentration is given Na. What Na is given in the problem? The value of Na is a 10 power 16 is given. 10 power 16 per cm cube is given. That much value. The next value, what is given here now? It is exposed to light such that the electron hole pairs are generated throughout the volume. When the light is exposed on this material, electron hole pairs are generated through the volume of the bar at the rate of 10 power 20 per cm cube per second only given. Generation is given. Generation rate what is given? 10 power 20. Yes, we can put. Generation rate is given 10 power 20. 10 power 20, what is given here now? Per cm cube per second. Per cm cube per second is given. That is the generation rate only now. And next one more parameter is given in the problem. What is given? The recombination lifetime is given. Tau. Tau equal to 100 microseconds it is given. 100 microseconds tau. 100 microseconds it is given. That much time. And still what is given in the problem? That's given. And the intrinsic carrier concentration Ni is given 10 power 10. Ni intrinsic concentration 10 power 10 per cm cube is given. 10 power per cm cube is given. Any more else given here? 10 power 10 per cm cube. 100% ionization is done. Okay. Then approximate the product of what is required? The whole and concentration product of the steady state. But now steady state what is given now? The problem what is asking here now? The product of the what now? The approximate product of the steady state and whole concentration due to this light exposure is. That means electron and hole concentration only now. Electron only steady state. Electrons and hole concentration. That what exactly? Electron and hole concentration is required. Product only required. Electron and hole concentration here now. Understand now? That what is missing I think now. Then we can write here now electron and hole concentration I want. N into P equal to how much? The question is electron and hole concentration clearly. Understand? It's missing I think now. But how I can get the product of N and P here now? Anybody can find here now? It is a p-type X6 semiconductor it is given. The p-type X6 semiconductor we want the P is nothing but acceptors concentration into the increased number of the holes because of the light illumination only now. Delta P how I can get here now? Because we know very well generation equal to we know very well delta P by what I can take delta P by tau allowed. Delta P and delta N are same only possible. Delta P and delta N will come same. It not be changed only now. But I can write the P is nothing but delta P is nothing but generation is given 10 power 20 and tau is given as a what now 100 micro. 100 into 10 power minus 6 micro. This can be written as a 10 power 22. This is a 10 power 20 into 10 power minus 4. finally 10 power 16 is possible. That much concentration possible. Na is nothing but 10 power 16, even this also 10 power 16. I can get as a what not 2 into 10 power 16 I can get. 2 times it is increasing. Per cm cube I am getting now. Per cm cube I can get only now. But here I would like to find the concentration of electrons also. Electrons can be taken as a what? But an initial number of electrons plus increased number of electrons only required now. Both electrons are required. That formula will be taken here now like this only now. But I can write as what now n0 plus delta n I can write. But delta n and delta p formula same only. G equal to delta p by tau, that equal to delta n by tau also. Same value. Delta p, because how many number of electrons are generating, that many number of the holes are generating only now. That's why we can write here now delta p and delta n are same only now. But n naught is nothing but the minority carriers in the what now? P-type extrinsic semiconductor. That minority carriers I can get only by using the mass action law. I can use the formula Ni squared by what? Majority carriers, that is a Na value, plus delta n same value 10 power 16. I can write here now Ni square, Ni is nothing but a 10 power 10 square, 10 power 20 I can get here now. Divide Na is nothing but 10 power 16 plus 10 power 16 is possible. The finally this n is nothing but this is a 10 power 4 plus 10 power 16 only now. But this 10 power 4 is a very small as compared to the 10 power 16, approximately equal to 10 power 16 only I can get. Per cm cube I can get. Now the product of these two required, n into p, is asking to find. N is nothing but how much here? N is nothing but 10 power 16 here. And p is nothing but we are getting the p 2 into 10 power 16 I can get now. And finally its value, then directly you can put now 32 is available, is it not now? 2 into 10 power 32 is possible. That much concentration is possible. This is possible per cm power 4. Cm power 6 only possible now. N into p only now. We can check which option is correct here now. 2 into 10 power 32. 2 into 10 power 32 means I can write as option C is correct only we can say. But in the question you try to change here now the steady state what now? Electron and hole concentration. Electron and hole concentration must here now. And hole concentrations due to the light exposure is now. But these are the questions are asked in the gate. These are all the questions are asked in the gate only now. Understand my point now. I think you followed. Thank you.